children, welcome to my channel. Now we are going to start with the congruence of triangles. Hope you would have gone through my introduction to this congruence in the previous video, and you would have understood the different criteria that we are going to use to prove the triangles are congruent. Now we will start with the problems. Now the first question, given here is AB is parallel to CD. So whatever data you are getting, whatever you can draw it, you mark it in the figure, you should mark. Now AB is parallel to CD, so you will mark it like this. And O is the midpoint of AD. So AD O is the midpoint, means now here AO is equal to OD. So that means AO equal to OD. Now you have to prove the two triangles are congruent, and also you have to prove O is the midpoint of BC. O is the midpoint BC means you have to prove OB equal to OC. Okay. So now what are the data available with us? AO equal to OD. One side is available. Now we need either on one more side, or either we need either two sides in one angle or two angles in one side. So what is the data given? AB is parallel to CD. So immediately you should check whether alternate interior angles are possible. So you can take these two angles. So this we will put it as 1 and 2. So alternate interior angles are equal, and also you can take these two as equal. Why? It's because vertically opposite angles. So 3 equal to 4. So now we are going to use ASA. So we will write it while writing also the steps, we will write it in the same sequence. So before starting, you find out what are the data available and which criteria you are going to use, and you write it in the same sequence. So we will start with, consider the triangle COD and triangle AOB. So angle 1 equal to angle 2, and you have to write the reason also. Alternate interior angles AB parallel to CD given. Then the next is OD equal to OA, that is side is given. Then we have angle 3 equal to angle 4. Vertically opposite angles. So write it in a box so that it looks neat. So now you can say triangle. Now while writing this, you have to write it in the proper sequence. DOA, triangle DOC is congruent to triangle. So what is corresponding to DO is AO. After DO, first is angle D, so corresponding to D is A. Then DO means AO. And then comes angle 3, so angle 4. So you have to write DOC means triangle AOB. It is ASA criteria. So the first thing what you have to prove, we have done. A triangle AOB is congruent to triangle DOC. Now you have to prove O is a midpoint of BC, that is OB equal to OC. So that we have to take from the the congruence, that triangle, that is from here we have to check whether you are getting that. So, OB equal to OC, OB and OC, yes. So, OB equal to OC. For this you will write CPCT, it is corresponding parts of congruent triangles. So, in your test you do not have to write the full sentence, you can simply write CPCT. So, you have got the required result. Now, we will go to the next problem. Here it is given AD and BC are equal perpendiculars. BC, okay. AB is a line segment, AD and BC are equal perpendiculars. That means this here it is 90 degrees and they are equal perpendiculars. That means BC angle B equal to 90 degrees, angle A equal to 90 degrees. Also the perpendiculars are equal, that is BC equal to AD. You have to prove CD bisects AB. So, CD bisects AB, that means you have to prove these are equal. You have to prove it. CD bisects AB, that means OB, you have to prove OB equal to OA is what you have to prove. So, BC equal to AD, we will mark it in the figure. So, we have now two data are given. So, the third data we have to find. Now, we have one side, one angle. We can say these two angles are equal. It is 1 equal to 2 vertically opposite angles. So, we will consider the triangle BOC and triangle AOD. So, again we will write angle 1 equal to angle 2, angle vertically opposite angles. You have to write the reason also. Then we have angle B equal to angle A, again angle given. Then is BC equal to AD, is side given. Therefore, the two triangles are congruent. So, the same sequence we will write OBC is congruent to triangle OAD, AAS criteria. Now, you have to prove OB equal to OA. Now, we will check here OB and OA. So, you can write OB equal to OA CPCT. Hope you have understood. These are all very easy questions. First we will do easy questions and then we will slowly gradually go to little more slightly difficult sums. Now, in this question it is given OA equal to OB, OA equal to OB and OC equal to OD. So, here we will draw two lines so that you differentiate it. If you draw single line, then you will not know which are the sides equal. So, we will, to identify that, we will write it, draw the one line, two lines, three lines, etc. Yeah. Now, you have to prove triangle AOC is congruent to triangle BOD. Also, you have to prove BD equal to AC. So again you have two angles, two sides we know. So this is very easy, very easy question. You have these angles equal, vertically opposite angles. So the angle is in between the two sides. So you will use it is included angle between the two sides. So SAS criteria is what you are going to use. So consider the triangle BOD and triangle AOC. So for BOD, OB equal to OA, the side given. Angle 1 equal to angle 2 A, vertically opposite angles, and OD equal to OC, side given. Therefore, triangle again triangle AOC is congruent to, so you have BOD. Yeah. Now you also have, I will add one more question. You have to prove BD is parallel to AC. So from here you will get BD equal to AC, BD and equal to AC, CPCT. Will write BD equal to AC, CPCT. Now we also have to prove AC is parallel to BD. So we need alternate interior angles to prove it is parallel. For that we will check whether OAC, so we will write angle OAC, OAC, so OBD equal to angle OBD. You have to write it in the same sequence. So OAC is this angle is equal to OBD. Suppose I am writing this as 3 and 4. We got angle 3 equal to angle 4, CPCT again. Therefore, so alternate interior angles are alternate interior angle 3 equal to angle 4. So since alternate interior angles are equal, therefore BD is parallel to AC. Hope it is clear. Now the next question. In an isosceles triangle, prove that the altitude from the vertex bisects the base. So isosceles triangle means immediately you should take AB equal to AC. Sometimes they just give the sentence. Now you have to write the what is given. Sometimes they will give you AB equal to AC, then you can straight away write. So in an isosceles triangle, two sides are equal, so AB equal to AC. Now prove that the altitude from the vertex bisects the base. So base, that AB and AC are the sides, so BC is the base. So the altitude, so AP, So, this is altitude. So, AP perpendicular to BC is also given. Now, you have to prove the altitude bisects the base. Bisecting means dividing into two equal parts. So, base is BC. So, this AP is dividing BC means you have to prove BP equal to PC. So, now we will consider these two triangles. Triangle APB and triangle APC. So, you have now here we will check whether can we use RHS. So, right angle is there, that is P. This is right angle P we can use, and the hypotenuse is also available. If hypotenuse is there, then immediately you can go for RHS. If hypotenuse is not available, then you should go for some other criteria. So, here AB equal to AC, then you need one more side. For that we have AP is a common side for both the triangles. So, we can take AP. So, we will start with R. I will put this as 1 and this as 2. Angle 1 equal to angle 2 equal to 90 degrees, that is R. It is given. Then we have AB equal to AC, hypotenuse. This is also given. Then AP equal to AP side, it's a common side. You can draw the lines so that it looks neat, but don't waste your time in during exam. Just try to draw a rough figure like this. Now, we will write the sequence. Triangle APB is congruent to triangle A, then corresponding to P, again it is P only, and then PB is PC here. So, APC. RHS criteria. From this we can say BP and PC. BP equal to CP, CP, CT. So, that is what we have to prove. The altitude bisects the base. So, BP equal to PC. Here, if the altitude from one vertex of a triangle bisect the opposite side, prove that the triangle is isosceles. It is exactly opposite to the previous sum. The previous sum, the sides were given now, and you have to prove it, the altitude is bisecting the base. Here, the altitude is bisecting the base, you have to prove the triangle is isosceles. So, what is given? The altitude. So, AP is the altitude. So, AP perpendicular to BC. So, and we will put like this. It is bisecting the opposite side. So, that means BP equal to PC. You have to prove the triangle is isosceles. That means AB equal to AC is what you have to prove. Now, you are going to consider the two triangles. Triangle APB and triangle APC. Here, while writing, you can write any sequence, because you are just considering the triangle only. When you are writing the congruent only, you have to write the same sequence. So, now here which criteria shall we use? You have right angle, but you do not have the hypotenuse. AB equal to AC is what you have to prove. It is not given. So, you cannot use RHS. The previous sum AB equal to AC was given. So, we used RHS. Here now we have to see what else we can use. So, angle is there. Now, BP equal to PC is there, one side is there, and then we can take AP as common side. So, the angle is in between the two sides. So, we will be using SAS. So, BP equal to PC, side given. Then angle 1 equal to angle 2 is angle given, and then AP equal to AP is side, it is a common side. Therefore, triangle BPA is congruent to triangle CPA. SAS criteria. Now, you have to prove BP equal to PC. So, we will check here BP and CP. So, therefore, BP equal to CP, CPCT. So, hope you have understood all the problems. So, please practice it. Once you keep practicing, will slowly the concept you will start understanding the concept, and then it becomes easier. The difficult problems it will become much easier for you to navigate through. So, I will see you in my next video with more problems. Till then, keep practicing, and bye to all. If you like, please share it with your friends and subscribe.